So with these related rates of change problems, they are tricky. They're tricky because there's not really like a one-size-fits-all process. You need to be pretty flexible with the way you approach it. But a general approach that I would try to follow is to always, and it's probably the same for any maths problem, write down what you know. Specifically looking at rates and constants, now to be really, really clear about what, when we're talking about rates, what's that usually got to do with?
Tangent.
Rates of change are talking about tangents in derivatives. What is a rate usually dealing with? Increase with something over time. Not always over time. Now, how do you know if it's going to be something over time? What will we see in our d something divided by dt? So when you're dealing with time, you should have dt, correct? So that's our first step. Write down our rates and our constants. Then our first question, we had, what did we know? What did we know in our first question? We had, the radius of a sphere is increasing at 4 centimetres per second. What is the rate of increase of the surface area when the radius is 9 centimetres? So what do we know? What's increasing? What is? So wouldn't that be dr dt equals 4 centimetres per second? Do we know anything else? We want to know the surface area, the rate, so we want...
But do we know the rule of it?
I'll tell you the rule in a sec. We want that, don't we? Is there anything else we know?
Should we know the radius?
There's probably something that we need to know about surface area for spheres. So I'm going to give you the surface area for a a sphere equals 4 pi r squared.
Will we get any of these rules in the exam?
I'd advise that you learn them. Now, is there something else we can get out of that information? So now we need to identify what we want and create an equation. So what's our equation? What do you think our equation is going to look like in this scenario? What do we want? We want dA dt. Is there a way we can get dA dt with dr dt and this equation?
Chain rule.
Chain rule. What's the chain rule? dA dt equals dr dt times dA dr. Now we're missing one thing here. What are we missing? We're missing dA dr. We've got this. So we've got that. We want that. We know we can't find that yet, but we need this. Is there a way we can get that? Rearrange? Is there something else we should do? Derive. This gets us to 3. Derive A. So A equals 4 pi r squared. dA dr equals 8 pi r. Does that make sense?
Yes.
So we've done 1, 2, and we're halfway through 3. What we then need to do, and in this question it's nice and easy because they've given us one more value.
9.
R equals 9 centimetres. Why did they give us R equals 9 centimetres, do you think?
Is that what the surface area?
They want the surface area at that point, so where are we going to use the 9 centimetres? For what? Into here? Good. So we want, I'm just going to write dA dt equals, I'll make sure I can be seen, yep, good. dr dt times dA dr. I write down what I know. I'm going to drop my unit now. I don't have to. So I'm just going to write 4 times 8 times pi times r equals dA dt. Are we clear there, or was that too quick? Okay. I'm now just going to collect my like terms. Well, no, I'm not. I'm going to let r equal 9.
How come you wrote it as 8 times pi times r instead of
I wanted to show you what, because I'm about to do something pi. I could have done 32 pi if you were happy with that.
No.
Cool. So I've got 4 times 8 times 9 times pi. And that's where I've done it on the sheet with by, I'll do it this way. Now the units are important. What unit should I have?
3.
Is that it?
That's it. Now, it is easy. It's easy because the real steps here, this is the real step, identifying that equation. Sometimes that can be a bit of a step, finding out what our R value should be. If they don't give it to you immediately, you might have to find your R value. The other way these can get a bit trickier is if my area formula, for example, was like the area of a cylinder. Now, why would that be trickier? What's the area of a cylinder? Pi r squared plus 2 pi r h. Why is that harder? 2 variables. So in that case, they'll probably give you some information about h, where they'll say the height is twice the r. How would you do that? Let h equal 2r. If they gave you a value for h, you would sub that in for h. So you'd let h equal 10, for example. Does that make sense? So there's no one-size-fits-all approach to this, but if you follow the general process over here, you'll get yourself out of trouble. Now, in saying that, the best way to approach these is to have seen the type of problem you've seen